class. Let's start off today by introducing ocean currents. What does everyone know about ocean currents?
I don't know for sure, but I do know that it involves salinity and temperature.
I know it's a continuous directed movement of seawater generated by a number of forces acting upon the water, including wind, the Coriolis effect, breaking waves, cabling, and temperatures and salinity differences.
Wow, that's really good. How'd you know that?
That's Wikipedia.
Okay. Well, today in class we're going to be learning and studying how ocean water density is influenced by salinity and temperature. Also, what factors contribute to salinity and temperature change in ocean water?
1.
Not only that, but how it adds to thermohaline circulation. And finally, predicting what will happen to the ocean currents if global temperatures change.
Can you slow down? That's very scientific.
Let's start with what involves salinity. We can begin with the thermohaline circulation. Does anybody have an idea what that is?
It's part of a large-scale ocean circulation that is driven by global density created by heat and freshwater flux.
Very good. Do you know why that is important?
Because it has to do with the world.
You're close. What is the world?
A planet?
Well, a globe. Global temperatures. Why is thermohaline circulation important for global temperatures?
Important because it brings heat to polar regions, which then influences sea ice formation. And that's not only the reason thermohaline circulation is important.
Very true. It is also important for life in the ocean. Marine life is crucial to thermohaline circulation.
I remember learning about this in middle school. Many fish get their food through current and expect for the current to bring it to them. Important nutrients from the deep help the fisheries and ecosystems. It supports the growth of phytoplankton and seaweed, which helps the energy boost for the sea animals at the top of the food chain. But there's something else. I can't pronounce it. It begins with an S.
Salinity?
What is salinity? Salinity is a concentration of salts in water, and the factors change the salinity in snow, rain, ice melting, and river water. Salt makes seawater more dense than freshwater, and salty water needs to be colder than freshwater before it freezes. Primarily, salinity is caused by natural processes such as accumulation of salt from rainfall over many thousands of years, or from weathering rocks. Salinization of streams and rivers can be threatened ecosystems and their constituent species and may render the water unsuitable for human users.
Wow, Nate. That was relatively smart. How did you answer that?
The student's best friend, the internet.
Well, if it works, it works. To help you better understand salinity, let's do a model.
So for this experiment, you'll need 4 beakers, food coloring with at least 4 different colors, a measuring spoon, salt, a test tube, and a pipette. Start up the experiment by making sure that the beakers all have the same amount of water in each of them, so add 150 milliliters to each beaker. Then add the food coloring. Then mix the colors into the water for a solid color. For the first beaker, which is our red beaker, add no salt to the beaker. For our second beaker, which we made yellow, add 1.5 tablespoons to it. Mix with the spoon to make sure all of the salt is mixed into the water. Our third beaker, which is green, we add 3 tablespoons of salt to it. Then mix the salt into the water so that they blend together. Next, our last beaker, which is blue, we add 4.5 tablespoons of salt to the beaker. We mix the salt in well to make sure that the salinity is there. So using the pipette, we take the blue water, which has 4.5 tablespoons of salt in it, and slowly squeeze it into the bottom of the test tube. Next, we take the green mixture, which has 3 tablespoons of salt in it, and we squeeze it into the bottom of the test tube, but we pour it down the side gently so that it doesn't mix with the blue. Then we take our yellow test tube and do as the same as we did with the green mixture, and our yellow has 1.5 tablespoons to it. And lastly, the red liquid, which has no salt, and slowly squeeze it into the test tube. Now you should be able to see almost a rainbow of colors inside your test tube. This experiment works so well because when salt dissolves into fresh water, the density increases. So when we add the most salt to the blue water, it weighs the most. So when we stack the lighter liquids onto it, they just sit there and they don't mix. The lighter liquids are able to stay on top because their density is lighter. Wow, the final product of the model looked really cool.
It really showed the significance of salt in the water.
Not just the water, but also the ocean.
Let's introduce another scientific topic. Does anyone know what halocene is?
I have no idea what halocene is.
Take a guess at least.
From the book, halocene is a sharp change in salinity with depth. It is usually well developed in coastal regions where there is much more freshwater input from rivers producing surface waters of low salinity. A zone where salinity increases rapidly with depth. A deeper zone of more saline, denser waters, therefore an ocean.
Let me further explain.
As you can see, this is a halo-saline graph. In it, you can clearly tell that there is a dramatic change in salinity with depth. When you go down 100 meters, the salinity in PSU goes from 32.9 to 34.5. After going down to 200 meters, the PSU of salinity stays at a constant rate. This makes sense because water with a higher concentration of salinity sinks below water that is less saline. Therefore, having saltier halosalines lie below less salty ones.
Everything that we've gone over so far has been about the first factor affecting density, which is salinity. Now that everybody understands salinity, let's talk about the second factor, temperature. Nate, I know that you understand salinity, but what about temperature?
I still do not know.
Mate, it's simple.
Fine, Nate. You can use your phone for this one.
Alright, good.
Unbelievable.
Wait, so I can use my phone?
Yeah, I don't get paid enough to care.
Temperature and density share an inverse relationship. As temperature increases, the space between water molecules increases, also known as density, which therefore decreases. If the temperature of water decreases, its density increases, but only to a point. At a temperature of 4 degrees Celsius, pure water reaches its maximum or peak density, cooled, further expands, and becomes less dense than surrounding water, which is why when water freezes at 0 degrees Celsius, it floats. Various events can contribute to change in the density of seawater. The difference of density of cold water versus density of warm water is responsible for the ocean currents and upwelling. Warm seawater floats and cold dense seawater sinks, so the ocean temperatures also vary across the surface and into the depths.
Good job using Google.
Why, thank you. I try my best.
Does everybody grasp the idea of temperature affecting density now?
Not exactly.
Let's try a model.
The things you need for the temperature experiment: hot water, cold water, food colorings, mini tub, and a spoon. First thing you need to do is fill 1 cup with hot water and the other with cold water. Put the green food coloring into the hot water. Then put the yellow food coloring into cold water and stir. Stir each cup so the color spreads. Then take the mini tub and fill with yellow cold water. Next, slowly put the hot green water in. Watch how the green water stays at the top and not mixing with the yellow. As you can see, you can put the colder water in first, then the hot water. The hot water stays at the top. This is because of density. The experiment works because the temperature making the water has different densities. Since cold water is more dense than the hot water, it remains at the bottom and stays down. Since the hot water is less dense, it goes over cold and stays up. They do not mix or blend together because of the drastic density difference.
Gabby, did this model help at all?
Yeah, it really showed the difference between hot and cold water, also how important it is to density.
Did you know that that temperature model we just did also involved thermohaline circulation from earlier?
Yeah, duh.
Do you think it could affect climate change?
I don't care.
I think I have an idea.
Well, what do you think would happen to thermohaline circulation if climate change continued to raise Earth's atmospheric temperatures?
It would spread warm water and heat faster. It's responsible for bringing heat to the polar region, so if the water happens to be warmer, it could begin to melt the ice there. It would add more fresh water to the ocean, decreasing the salinity. This would prevent cold water from sinking, and that would alter ocean currents.
Good answer! Looks like the bell's about to ring. Let's wrap this up.
Wait, what was the point of this anyway?
Let's talk about the ocean. More specifically, how salinity and temperature affects the ocean's density. And not only that, what factors affect thermohaline circulation in the ocean? Also, as a class, we made predictions on what could happen to ocean currents if the thermohaline circulation changed global temperatures. So exciting! There's the bell. Have a great day, class.